This is the second part for 14e. We're going to use our knowledge of a cos x plus b sine x and its transformation to solve equations. Here's our example. We want to solve the equation sine x minus root 3 cos x equals 1 within the domain 0 to 2 pi, but first we've got to convert this into the form r sine x plus beta or r cos x minus alpha. I'm going to convert it into y equals r sine x plus beta because we haven't looked at this one before. Just notice here, in our equation we normally have a cos x plus b sine x equals r sine x plus beta. In my equation that I was given in the question, I have sine x first, so I'm just going to flip these around to make sure I don't make any mistakes with my a and b. So now I have y equals minus root 3 cos x, if I put that first, plus 1 sine x. This makes it better because my a I can identify as minus root 3 and my b is a plus 1 or positive 1 outside the sign. Like all conversions, we want to find r and then beta. So r is the square root of a squared plus b squared, or in our case, we take the square root of minus root 3 squared plus 1 squared. That will give us the root 4, or r equals the positive of the root always, 2. Sine beta equals a over r. Our a is minus root 3, and our r is 2. Cos beta I also need to find. That is b over r. B is 1, and again r is 2. I'm going to use the sine beta and the cos beta that I have to notice and figure out what beta is. So sine beta is a negative root 3 over 2. Cos beta is positive. Which quadrant is beta in? Is it acute, obtuse, or reflex, etc.? If I use my unit circle, I know that sine is negative in quadrant 3 and 4. Cos is positive in quadrant 1 and 4. Therefore, sine is negative in Q4 and cos is positive in Q4. So beta must be in this fourth quadrant. All right, I'm going to draw in my unit triangle. And I know that cos of the adjacent side is a half. Sine, the opposite side, is minus root 3 on 2. And from my memory, I know that that angle beta must be minus, because we're going down from the x-axis, minus pi on 3. I can write y equals 2 sine x minus pi on 3. That's the first part. Now let's solve the equation. So we know that sine x minus root 3 cos x can be written in the form 2 sine x minus pi on 3. Before I attempt to solve this, I'm just going to make a rough sketch of this function. I know it's going to cross the x-axis and pi on 3. I know the amplitude is 2. There's no vertical shift. So it's going to look something like this. My very dodgy graph has a range from 2, -2. It will hit the x-axis at pi on 3. It will look like a sine function. And then it will hit the x-axis again if I plus 2 pi to pi on 3. That's about 7 pi on 3. And if I minus 2 pi from pi on 3, because the period is 2 pi. So it will hit the axis again at -5 pi on 3. I'm going to use this to help me figure out what type of solution I expect to find. Okay, now let's get on to the solving part. So I want to solve this equation when it's equal to 1. So instead of having 1 equals sine x minus root 3 cos x equals 1, I can simply have 2 sine x minus pi on 3 equals 1. If I go back to my graph and I just draw a line where y equals 1 between 0 and 2 pi, because that's my domain, notice that I think there will be 2 solutions or 2 points of intersection. Both of these look like they're positive between pi on 3 and 2 pi. That will help me figure out, is my solution reasonable? And if I get more than 2 solutions, I'm going to have to double check and be like, what did I do wrong? Now, let's use a little bit of trick to find the 2 possible solutions. All right, first solution. What we have to do is take our 1 equals 2 sine x minus pi on 3, and let's move the numbers outside or around the sine function to the other side. That way I'll get a half equals sine x minus pi on 3. I know that sine theta equals a half. Using my unit circle, I'll just put in the values. Hypotenuse is 1. Opposite is a half. Adjacent is root 3 on 2. And I know that sine theta equals a half when theta equals pi on 6. So I could say x minus pi on 3 has to equal pi on 6 plus pi on 3 to get x by itself. And I'm going to get my first solution. X equals pi on 6 plus pi on 3. That will be x equals pi on 2. But recall, that's not the only solution that I have. So let's do the same thing, but think about another value in which sine theta equals a half. I know, using my unit circle, that sine theta is positive in the second quadrant, or if we have an obtuse angle. So let's let this angle be x minus pi on 3 again. And again, drawing our unit triangle. Hypotenuse 1, opposite a half, adjacent root 3 on 2. I know that that angle there must be, from the x-axis all the way around, 5 pi on 6. So I end up with theta, or x minus pi on 3 equals 5 pi on 6. Again, move the negative pi on 3 by adding it on to the other side, and we get x equals 7 pi on 6. That kind of corresponds with what I got in my graph. Notice both of these solutions are within our domain, 0 to 2 pi. So I can mark them off as correct. Just a quick note, if I changed the domain to say minus 2 pi and 2 pi, if I continued my y equals 1 line, I would probably get actually 4 solutions in total. So to find the other 2 solutions, we take the solutions that we got, pi on 2 and 7 pi on 6, and we would subtract our period from both of these. I'd take x1, pi on 2, subtract 2 pi, take x2, which was 7 pi on 6, subtract 2 pi, and that way I will find out, if I had the domain extended, those 2 extra solutions. If the domain was even bigger, you would continue to do this by either adding the periods or subtracting the periods from your solutions. And if you put this on the calculator, okay, we can see that our answers are correct. So good job. So minus 2 cos x plus pi on 6 is the same thing as 2 sine x minus pi on 3. Continue with 14e.